going on page 80 when we are done. Okay, so we're going to look at angles in the coordinate plane. This part should definitely be a review from geometry. So an angle in the coordinate plane, an angle on the coordinate plane in standard form or standard position is when the vertex is on the origin and one ray lies on the positive x-axis. So this angle over here is in standard position. I have one ray on the positive x-axis. The vertex is at the origin. Then we have the other ray that is wherever it is to make the angle, okay? That's in standard position, your angle on the coordinate plane, okay? We good? All right, so the ray on the x-axis is called the initial side. This is where you start. The other ray is called the terminal side because that's where you end. Okay, initial and terminal side. So you can rotate two different ways. You can rotate counterclockwise or you can rotate clockwise. So we got counterclockwise and clockwise. And they result in two different kinds of angles. You can tell me positive and negative. So counterclockwise, which one is that? It's actually positive. Okay, counterclockwise, well, it's the opposite of a clock. So a clock goes around like this. This is counterclockwise. Okay, so to talk about that, let's talk about the quadrants. Where's quadrant 1? Top right. Okay. And then quadrant 2, top left. And then we go around this way, right? So counterclockwise. When you first learned the quadrants, did you think that was kind of dumb? Yeah, me too. And like if I was able to choose it, I probably wouldn't have done that. I probably would have gone 1, 2, 3, 4 because we're used to things going left to right. Seems to make more sense when you first learn it, right? But then everything else starts to kind of make more sense now. The reason they go like that is that's how the angles increase. Because when you go positive, you're here at 0, then the angle opens up this way. You go 0, 90, 180, and you get bigger and bigger. And that's why it's 1, 2, 3, 4 that way. Okay? Does that make sense? That's why it's like that. Can't really explain that to you necessarily when you first learn them because that would just not make any sense at all because that's just, things are weird anyway at that time, right? So counterclockwise rotations result in positive angle measures. Clockwise rotations result in negative angle measures. So in geometry, when you were rotating figures, let's say we're just going to rotate a rectangle 90 degrees. The rule is it's counterclockwise unless it's told otherwise, because you're not really told to do it negative and positive at that point. Then we do talk about angles like this. But counterclockwise is the way you go unless you're told otherwise. And the way you're told otherwise now is basically if it's positive or negative. Okay? We good? All right. So, degrees. The most common unit of measure for angles is the degree. And there's your little degree symbol, right? Before geometry, it's the only way you knew that you could measure angles was in degrees, right? Then we learned about radians. So your degrees, we're here at 0, 90, 180, 270, 360, right? So all the way around is 360 degrees. That's a full rotation. So a degree, meaning just one, there you go, is 1 out of 360 the full rotation. 1/360th, just a fraction. So 1 degree is 1/360th of a rotation. All right, so now we're going to sketch them we're going to sketch them in the coordinate plane. So we got this 135. So I know that my angle starts on the positive x-axis. This is a positive 135 degrees, so I know I'm going to rotate counterclockwise. Well, I know that if I go from here to here, that's 90, right? So if I subtract 90, what am I left with? If I subtract 90 from 135, 45, okay? So that means I go 90 degrees and then another 45, which means I know that that is halfway. It's going to look like this. This right here is 135 degrees. Okay? And you show that you're doing that positive rotation. We good? All right. So then 495. All right. Well, I know that if I start here and go all the way around, that's 360. So I'm going to subtract 360, and what am I left with? 135. So it's going to end up in the same spot. I start here, I end here, but it's not the exact same angle, right? So I have to start here, I go all the way around, and then I end up there, and that is 495 degrees. Okay? You good? Okay. So now I have a negative angle. I still start here, but I'm going to go clockwise, right? So I'm going to go clockwise. I'm going to go 90 this way, and then how much more would I have to go? 50, which is just a little tiny bit past halfway, which will probably still look about halfway, and that's fine. And then this is negative 140. Yeah, I just think in terms of 90s, like how I've got 91, you know, and if that was, let's say that was 195 degrees, then I would have said, all right, well, I know I'm going to go 180 and then a little bit more, that sort of thing. You just kind of think in terms of the quadrants to subtract it out. Does that help? Mm-hmm. Questions at this point? All right. So now let's talk radians. All right. So a radian is a unit of angle measure based on arc length. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. Okay? So that sounds way more complicated than it is. The radius is the same all the way around the circle, right? So if I could pick up the radius and then bend it around the circle right here, right there, that is a radian. We'll talk a lot about the unit circle, so the radius is always 1. But if the radius was 15 inches, then 1 radian would be 15 inches, because we're talking about a unit circle, right? And then it would be 15 inches would go around the circle 2 pi times. Okay, that's the way you do it, 2 pi times r, right? Here's a little animation of the unit circle, right? There's no sound or anything. There's not even a play. Where's the, oh, there's a place over here.
We start with a circle of radius r.
Boom, there's your circle, right?
We take that radius distance and wrap it around the circle.
And see how it just bends around the circle?
The angle formed by that radius distance is 1 radian.
Right there. That little red thing that was
Since the circumference of a circle is 2 pi r, there should be 2 pi radiuses in a circle.
That's pi radians.
So halfway around the circle, we would expect 1 pi radian.
That's what a radian is.
And around the entire circle, we would expect 2 pi radians.
That's why 2 pi times r.
A radian is the angle.
This explains all the rest of that stuff. But so 2 pi r is the circumference. When radius is 1, you just go around 2 pi times. So we're talking arc length here. So we know that 360 degrees is 2 pi radians. And 180 is pi radians. Right? Not only is that from geometry, but we talked about it again at a little crash course right before the SAT, just to kind of remind ourselves of that. So it's just like a normal conversion. There's 12 inches in 1 foot. There's 180 degrees in pi radians. It's the same type of conversion. So if I'm trying to convert from degrees to radians, I take the degrees that I have, I'm going to multiply it by pi over 180 so I can get the pi in there, because there's pi radians and 180 degrees. If I want degrees, I take the radians I have, multiply by 180 over pi. It's very difficult to do it the wrong way, like to have your fraction backwards. You can have radians in decimals. Okay, most of the time we look at stuff in exact form, so it'll be really obvious that there's a pi in there. And so if you multiply this by pi over 180, that makes absolutely no sense, because then you get pi squared in the numerator, right? The whole idea is that you're trying to divide it out. So we're going to convert each one of these, and we're going to state the quadrant. But we're actually going to state the quadrant first. So if I have a 60-degree angle, what quadrant am I in? First quadrant, okay? Easy question. Okay, so I'm in quadrant 1. So now I'm going to take this 60, and I'm going to multiply it by, since it's in degrees, I want it in radians, so I do pi over 180. I can put 60 over 1. Zeros divide out. 6 goes into 18 how many times? 3 times. So I end up with pi thirds. Okay, easy enough? Eventually you're going to have to just know that 60 is pi thirds. I don't expect you to know that right now. We just have to be able to find them right now. Okay. So 160, what quadrant would I be in? Second quadrant. Okay, so I'm going to take that 160 and I'm going to multiply it by pi over 180. Zeros cancel out. Then I can divide these both by 2 and I'll get 8 over 9. Can I reduce that anymore? No, so I get 8 pi over 9. That is not one that you would just have to know. That's one that you could go and figure out. Okay, so there's certain ones that you'll have to know and other ones you wouldn't be expected to know. You just have to be able to find. All right, negative 330. What quadrant would I be in? first one. Negative 330. So negative 360 gets me all the way around, right? So I only have 30 more to go, so I'd have to be in the first quadrant. Does quadrant 1 make sense? Okay. So then I'm going to take this negative 330, and you want to make sure you don't lose your negative sign, times pi over 180. Zeros cancel out. I can divide both of these by 3, so this will give me negative 11 over 6. This is negative 11 pi over 6. Easy enough? All right, so now coming up with the quadrants with degrees, not so bad, because you understand degrees and you're comfortable with them. Now, we could convert these and then figure out the quadrant, but we're going to do it the other way first. Okay, we're going to figure out what quadrant it is, thinking in terms of radians, and then once we get it in degrees, we can double check ourselves. Okay, but this is where you're going to push yourself out of your comfort zone a little bit. Now, you have a little bit of room over here, and I don't think you have any room down here, but what I'm going to draw right here, you might be able to draw right there. I'm just going to draw a little X and Y axis here. So I know that this is 0, and if I go all the way around, it's 2 pi. Right? So if I go 180 degrees, what would that be in radians? Pi. So this is 0. If this is 2 pi, this is just pi. I'm halfway. Make sense? So what would this be right here? Pi over 2. And you would never, ever, ever write 1/2 pi. It's pi over 2. It's always all in one fraction. Now, here's what I mean by count fractionally and think fractionally. Like, it's going to be easy fractions. It's not that big of a deal. But if I want to talk, obviously, 90 degrees is pi halves, right? In our quadrants, we think about 90 all the way around. So this is at 0. This is pi halves. So isn't this 2 pi halves? Right? So 2 pi halves just becomes pi when you reduce it. So then what would this be? 3 pi halves. And then this is 4 pi halves, which is 2 pi. So you want to be able to count in whatever denominator you end up with. Okay? And if you can count around the circle that way, and you can start thinking about the circle that way, it'll make everything we do a ton easier. Okay? I mean, fractions, I know that word is scary to some of you, but we're not adding, subtracting, multiplying, and dividing fractions like crazy. It's just being able to think fractionally, which you can totally do. So with that said then, what would 45 degrees be in radians? 45 degrees. What would that be in radians? Pi over 4. Does that make sense? Because this is pi halves, so halfway would be pi fourths. So if I think around the circle that way, this is pi fourths, this is 2 pi fourths, which is really pi halves, right? So what would this be? This is pi fourths, 2 pi fourths, 3 pi fourths, right? 4 pi fourths, which is pi. This would be what? 5 pi fourths. This would be 6 pi fourths, which is really this. So this would be 7 pi fourths, and then this would be 8 pi fourths, which is 2 pi. Okay? So if you can start thinking that way and understand how that works, when you actually learn them and learn how to remember these, you'll be able to think around the circle very quickly. And once you fully understand the first quadrant, the rest of it becomes very, very easy. Okay? Nothing. All right, so now let's use that theory, that thinking, to figure out the quadrant for this. 5 pi 18ths, right? So if I'm thinking in 18ths, this is 18 pi 18ths, right? So this is 9 pi 18ths. Make sense? So what quadrant is 5 pi 18ths in? First quadrant. Okay, it doesn't tell me the angle measure right now, but I know what quadrant it's in. Does that make sense? That's all I want you to get out of that right now, like baby steps, okay? So we're in the first quadrant. And then once we convert it, we can double check that we're right. Okay. So now I'm going to take this, and I'm going to multiply this by 180 over pi. So the pi's will cancel out. 18 goes into 180 how many times? 10 times. So I really just have 5 times 10, which is 50 degrees. Is 50 degrees in the first quadrant? Yes, then we were good. Okay? Everybody okay with that? All right. So then I have negative 11 pi ninths. So I know I'm going this way, right? Going clockwise. So this would be 9 pi ninths. So where's 11 pi ninths going to be? Second quadrant. So then I can actually convert like I'm supposed to. I'm going to multiply this by 180 over pi. The pi's cancel out. 9 goes into 9 once, into 180 20 times. So then 20 times negative 11 is negative 220. Good. Okay, so negative 220 degrees. Is that in the second quadrant? Yes, because I'd go negative 180 and then another 40, so I'm good. All right, so then 7 pi thirds. All right, well, in pi thirds, this is 3 pi thirds, right? All the way around is 6 pi thirds. So 7 pi thirds is quadrant 1. Okay. So now I multiply this by 180 over pi. The pi's will cancel out. 3 goes into 3 once, and the 180 60 times. So I just have 7 times 60, which is 420 degrees. All right, so that means I go around 360 degrees, and then I'd have another 60 to go, which would be in quadrant 1, so I'm good. Okay. What questions do you have? Any questions at this point? Yes, it does. All right. So now, coterminal angles means two angles that terminate in the same spot, but they're not necessarily the same angle. So if we start here, right? Everybody starts at 0. I can go a positive 90 degrees or a negative 270 degrees, and I end up in the same spot, right? Just like if we went outside and we were running around the track, we could both start in the same spot, and if we run in opposite directions, well, when we run into each other, we ended up in the same spot. We just got there a different way, right? We could even lap each other, right? We could keep going around and around and end up in the same spot. So it's not just like it's one rotation. Another coterminal angle would be if I went all the way around like this, or even if I went all the way around like this again, okay? So if I wanted to find that mathematically, if I have 90 degrees, and I want to figure out the coterminal angle of a negative 270, what could I do? How do I get this number? If I have 90 degrees and I want to know what is a coterminal angle. Okay, yes, I could multiply it by a negative 3, and that would work here. You're right. It's not a wrong answer. But would that work for every single angle? No. You kind of get lucky on that one. But what else could I do? How do I figure out, if I'm here, how else I could get here? I could subtract 3. If I took 90 and I subtracted 360, would I get negative 270? And if I was here at 90 and then I added 360, wouldn't that give me another coterminal angle? Right? So I could either add or subtract 360 degrees, and I'm going to put times n, okay? Because I could do, 720 or whatever. I could do more than one rotation. In radians, that would be plus or minus 2 pi times n. N usually being 1 when you're having to figure something out. There's no reason to get crazy, but you could do it by any multiple of that also. All that really means. So on number 10, right, 10 through 13, it gives us two angles, and we want to know if they are coterminal or not. So if I take that 305, and I want to know if it's coterminal with negative 55, I can subtract not 60. They are, because if I subtract 360, I end up with a negative 55 degrees, so the answer is yes. Make sense? Then here I've got 30 and a negative 170, so I can do 30 minus 360. Well, that gives me a negative 330. Now, just because you don't get the answer the first time doesn't mean that the answer is no. Because remember, I could subtract 360 again, or I could have added 360. But if I add 360 to this or subtract 360 again, I'm still not going to end up with that, right? So then the answer is no. They should subtract to 360. Does that make sense? Like, so 305 minus a negative 55? Yeah, they should make 360. Well, or some multiple of it. Because if it was some big number, like I could have a huge angle and a really tiny angle. No. Well, 90 is not a multiple of 360. 360 is a multiple of 90. Does that make sense? I know. All right, so now we're going to do this with the radians, right? So for the radians, yes, it's 360, but what's 360 in radians? 2 pi. So, and we need to do this in fourths. So 2 pi, and since this is negative, that's why I'm subtracting. 2 pi in fourths is what? 8 pi over 4. Okay. So then this is going to give me negative 7 pi over 4. Now again, it doesn't match, but if I subtracted another 2 pi, am I going to end up with negative 9/4? No, I would just end up with something else. So the answer here is no. All right, so I'm going to take 3 pi halves, and I'm going to subtract what? What is 2 pi in half? 4 pi halves. 4 pi, because I'm subtracting 2 pi. 2 pi in halves is 4 pi halves, right? So I subtract that, and I just get negative pi halves. Now, it doesn't match, but could I subtract 4 pi halves again? Yes. And this time, if I subtract 4 pi halves again, that actually gives me negative 5 pi halves. So the answer is yes. You have to be able to think fractionally, quickly, and accurately. So now we're asked to give two coterminal angles, one positive and one negative, which means in most cases you can take what you have, add 360, and then subtract 360. But you may have to do it more than once depending on the angle. So I have 150. I'm going to add 360 to it, and I'm going to take 150, and I'm going to subtract 360 from it. When I add them, I'm going to get what? 510. When I subtract them, I'm going to get negative 210. So there's one positive and one negative there. Then I have 7 pi sixths. So I've got to take my 7 pi sixths. 12 pi over 6. I know what you meant. And then 7 pi 6 minus 12 pi 6. Everybody understand how we're getting that number? Yes. Okay, speak now if you don't. So this is going to give me 19 pi over 6 and negative 5 pi over 6. Everybody okay with all that? All right, then you do number 16. All right. What questions do we have? Are we good? Yes? Okay, good. So now we're going to talk about reference angles. Okay, so we should have already learned how to graph the angles. Like that was not a new part that we did on the front. But now we got to think about where they are and be able to think about the reference angles. The reference angles are what we're going to use more than the real angles. If you understand what reference angles are and how to find them, and then you understand the first quadrant perfectly, everything else becomes very, very easy. Okay? Not exactly. No. All right, so first we're going to graph. So it says for an angle of theta in standard form, the reference angle is the, here's important, positive acute angle, and this should say formed by the terminal side and the x-axis. Okay? Not the y-axis. The x-axis, it's always positive, it's always acute. So it doesn't matter which direction you go to get to the x-axis, it's still going to be positive because it's not in standard form anyway. All right, so 150 degrees. Here's my initial side. So I would go 90 and then how much more? 60. And 60 is how far through the quadrant? It's what? 2/3. So 60 is 2/3 of 90. So I'll go 90 and then I go another 2/3, so I should be right about there. Although I don't expect you to get out a protractor and make it perfect, you should be trying to eyeball it pretty accurately. So this right here is 150 degrees. That's the angle we just drew. Now, the reference angle goes from the terminal side to the x-axis. Right here. Okay? This right here is the reference angle. How big is that angle? 30 degrees. So this right here is 30 degrees. And you will see once we start putting a unit circle together why those reference angles are so very important. Okay? So 150 degrees, your reference angle is 30 degrees. So now we look at 315. I know I'm going to start here, and you can think about these angles a couple of different ways. Okay, I could start here and, go around and how much it is. But also, this is pretty close to 360, right? How far from 360 is that? 45. So that means that I'm going to go around all but 45 degrees. So this right here is my 315, right? It's a little easier than doing all the subtraction and stuff, even though the subtraction isn't necessarily difficult. And then this is my reference angle, which I've already figured out by the way I tried to graph the angle, right? And this is 45 degrees. That's my reference angle. Okay, we good? Make sure they are drawn and labeled, and you have the actual reference angle boxed or whatever, because that's the answer. All right, so then I've got negative 240. All right, so I'm going to start here. I'm going to go a negative 180, and then how much more? 2/3. Another 60. So I'm here. So this right here is a negative 240 degrees. My reference angle is made by the terminal side and the x-axis. And again, because of the way I did it, I went 180 and then another 60, then I know that my reference angle right here is 60 degrees. Yeah, purple is the reference angle. All right, so we are going to do 4, 5, and 6 without converting, okay? I know that radians you're not super comfortable with, and I know that even though you should know that 45 is halfway and 60 is 2/3, with the radians, you don't necessarily understand that yet. So if you can get it in the right quadrant, I'm good enough with that at this point, okay? Get it in the right quadrant, know what the reference angle is. It's okay if you didn't really draw it correctly. I'll show you what I mean by that. All right, so 5 pi thirds. All right, so I know I start here, right? If I go around here, this is 3 pi thirds, right? And then this would be 6 pi thirds. So 5 pi thirds would be down here, right? So if you think about this, you've got 3 pi thirds, 4 pi thirds would be about 1/3 of the way, 5 pi thirds is another third, and then there'd be your 6 pi thirds. So you'd be about right here. This right here would be 5 pi thirds. Everybody okay with that? So then my reference angle is this angle right here, and what is it going to be in radians? Pi thirds. Because you had pi thirds more to get to that 6 pi thirds. Does that make sense to you? And it's not like, if I add those two together, I get 6 pi thirds, which is 2 pi. But you're not always going to add them and get 2 pi. It depends on where the angle ends up, right? But you should kind of be able to figure out what you should add or subtract to get. We good? All right, so now let's look at 13 pi sixths. I know I'm going to start here. This is going to be 6 pi sixths, right? All the way around is 12 pi sixths. And so then 13 pi sixths is where? 1 pi sixths. Right here. So all the way around, this is 13 pi sixths. That means I went 12 and I had to go one more. Again, we sort of figured it out when we figured out how to draw it. And so this is just pi sixths, and that is my reference angle. Everybody okay with that? All right, pi fourths, how many degrees was that? Pi fourths. Pi halves is how many? 45. Pi fourths is 45. So pi is 180, right? Okay, so we can already try and figure out some easy ones. Pi halves is 90, right? Pi fourths is 45. Okay, get those down right now, and in little bits at a time, right? Okay, so we got pi, we got 90, which is pi halves, and then pi fourths. Okay, so that means when we're in fourths, we'll know where it will be in the middle somewhere. So I'm here, right? I start there. It's negative. So this is negative 4 pi fourths, right? Negative 5 pi fourths, which means I go one more of them, and since pi fourths is 45, I should be in the middle. So this is negative 5 pi fourths. which means my reference angle is what? Yes, but in radians that is pi fourths. So we'll talk about quadrantals here in just a second. The quadrantal angles are the angles we should know first. Quickest, the easiest way to even think about them around the circle. So on these, when I ask you, like, what quadrant are we in? Well, this is in quadrant 4, this is in quadrant 1, this is in quadrant 2. But if you end up on an axis, you're not in a quadrant. Okay, so if you're not in a quadrant at 90, you're in between the quadrants, right? Those are called quadrantal angles. Right? So when it says, like, what quadrant are you in, your answer is, I'm not. You don't have to write that down, but you write that it's quadrantal, and then you do have to identify where you are. So it says when the terminal side of an angle theta is in standard position, lies in the x or y axis, and the angle is called a quadrantal angle. So when I'm at 0, or 2 pi, or 4 pi, or however many rotations I made, if I end up there, I'm not in a quadrant. It's a quadrantal angle, and then I say I'm on the positive x-axis. So if I'm at 90 or pi halves, then it's quadrantal, and I'm on the positive y-axis. If I'm at 180 or pi, then I'm on the negative x-axis. 270 or 3 pi halves, then I'm on the negative y-axis. Now, I want you to understand that understanding these radians, it's not even necessarily a memorization at this point. If you understand that this is 0 and this is pi, then you should be able to tell me real quick that 90 is pi halves, right? It's more of an understanding that that's pi halves. And then if you can count in halves, this is pi halves, 2 pi halves, which is pi. This has to be 3 pi halves right here. Make sense? And if you understand that 90 is pi halves, then 45 being pi fourths should make sense. And it's just more of an understanding how to get around the circle. Okay? Are we good so far? All right. What questions do we have? Anything? Awesome.